our CHEM 405 Societal Engagement Project, our team consisting of Bragi, James, Martine, Monique, Sidney, and Spencer has had the wonderful opportunity to collaborate with Phillips Brewing and Malting Company to study the effects of yeast fermentation on acids contained in Phillips sour wort. If you don't know, Phillips Brewing and Malting Company is a local business in the heart of downtown Victoria on Government Street. Since 2001, Phillips has been exploring the craft beer and soda frontier, becoming well established due to their creativity, such as their beautiful can designs and wide variety of quality beverages. Our team was fortunate enough to get into contact with Benjamin Schlottel, Phillips Quality Control Lab Manager, and his team to collaboratively design a chemistry project. For our project, we decided to investigate the acidic properties of their sour ale wort base, which is used to make their popular Dino sour ale collection. In this process of making the sour ales, wort is made, which is essentially sugary grain water or unfermented beer. Phillips adds their house-cultured lactobacteria strain to the wort, which creates a vast array of sour flavors. In particular, lactic acid and acetic acid are among the key contributors responsible for the tartness in most sour beers. With that in mind, we decided to investigate/monitor how the concentration of lactic acid and acetic acid in soured wort could change when going through the process of yeast fermentation. This would allow Phillips to better understand the potential impact of the fermentation on the taste of their final product. Phillips provided us with samples of their lacto-soured wort, so pre-yeast fermentation, and with their yeast-fermented sour wort, post-yeast fermentation. For the analysis of lactic acid and acetic acid, we used HPLC UV-Vis methodology from Tipler et al. Due to the resources offered to us, we had to change some of the parameters from Tipler's methodology. We used a shorter column, slightly higher buffer pH, 3 pH instead of 2.4 pH, and a lower flow rate, 0.5 milliliters per minute instead of 1.5 milliliters per minute. We prepared 7 lactic acid standards ranging from 0.01 to 2% weight by weight, and similarly, 7 acetic acid standards ranging from 0.001 to 0.2% weight by weight. We ran the samples and identified our acid peaks in the chromatograms and created calibration curves for them. We then ran triplicate samples and spikes of the prepared lacto-sour wort and yeast-fermented sour wort samples. We identified the lactic acid and acetic acid peaks in the chromatograms, and then calculated the average concentrations of the acids from the calibration curves. Highlighted in orange, we can see that the concentration of lactic acid stays the same within error when going through the fermentation process. Similarly, highlighted in blue, the acetic acid concentration stays the same. In conclusion, it was determined that there was no change in concentration of lactic acid and acetic acid when fermenting Phillips lacto-soured wort. T-tests were performed between the wort pre-yeast fermentation and post-yeast fermentation samples, which provided further evidence that the concentration values were not significantly different. This would mean that Phillips' fermentation process does not have a negative effect on the acid levels/tartness of their sour ales. A challenge we faced was the time constraints with the lab time. Unfortunately, we didn't have that amount of time to test/adjust HPLC parameters to achieve perfect chromatograms for the samples. Due to this, some peak overlap was present between lactic acid and acetic acid peaks in the sample's chromatograms, which affected the accuracy of our results. This can explain high sample spike recoveries that were calculated for both samples. That being said, not having limited time for the lab time and using a longer column would have allowed us to get better separation between peaks and therefore better accuracy in our results. We also tried to make multi-standards, but this was unsuccessful. In the future, better preparation of multi-standards would allow for better comparison of the acid peaks. Overall, we would like to give a huge thank you to Benjamin and the Phillips team for allowing us to collaborate with them on this project. Furthermore, to Irina and Emma for helping us with planning and performing our experiments.